Download this code from codegive.com, link in the description below. Certainly. The Edmonds-Karp algorithm is an implementation of the Ford-Fulkerson method for computing the maximum flow in a flow network. It uses breadth-first search, BFS, to find augmenting paths in the residual graph. This algorithm is particularly efficient for networks with integer capacities and runs in \o v \e_2 where \v is the number of vertices and \e is the number of edges. Key concepts: 1. Flow network, a directed graph where each edge has a non-negative capacity and the flow must not exceed these capacities. 2. Source and sink, the flow network has a source node, where flow originates, and a sink node, where flow is consumed. 3. Residual graph, a graph that represents the remaining capacity of the edges after some flow has been sent through the network. 4. Augmenting path, a path from the source to the sink in the residual graph that can accommodate more flow. 5. Flow conservation, the amount of flow into a vertex equals the amount of flow out, except for the source and sink. Steps of the Edmonds-Karp algorithm. 1. Initialization, start with zero flow in the network. 2. Find an augmenting path, use BFS to find the shortest path from the source to the sink in the residual graph. 3. Augment flow, determine the maximum flow that can be sent along the found path, this is determined by the minimum capacity of the edges in the path. 4. Update residual graph, subtract the flow from the capacities in the forward edges and add it to the reverse edges. 5. Repeat, continue finding augmenting paths and updating the graph until no more augmenting paths can be found. 6. Result, the total flow sent from the source to the sink is the maximum flow. Code example. Here's a Python implementation of the Edmonds-Karp algorithm. Explanation of the code. 1. Initialization, the Edmonds-Karp class initializes the number of vertices and creates an adjacency list and a dictionary for edge capacities. 2. Adding edges, the add_edge method adds directed edges and initializes the reverse edge capacity to 0. 3. BFS for augmenting path, the BFS method searches for an augmenting path using BFS and fills the parent dictionary to reconstruct the path. 4. Max flow calculation, the Edmonds_Karp method iteratively finds augmenting paths and updates the capacities until no more paths can be found. 5. Example usage, the last part of the code demonstrates how to create a flow network and compute the maximum flow using the Edmonds-Karp algorithm. Conclusion. The Edmonds-Karp algorithm is a classic method for solving the maximum flow problem in a flow network. It's particularly useful in applications such as network routing, bipartite matching, and resource allocation. The provided code gives a clear implementation that can be expanded for various applications.